Today we are going to see banking of road. Before I am going to explain banking of road, you know what's meant by a centripetal force. When you drive a bicycle or any two-wheeler, when you go in a curved road, you slightly bend inwards. You slightly bend inwards. Why are you bending? To provide centripetal force. You are bending, for example, this is the bike, you are going here like this. Then while going here, you are bending inside. You are bending inside. In order to provide centripetal force, you are bending inside. Okay, inside means this is the inner curve, this is the outer curve. Inside means this will be the center of the circle. If you consider this as a circle, then this will be the center. That means you are bending towards the circle, towards inner edge. Okay. Now, when you drive a two-wheeler, you can bend. Then how can you bend when you drive a four-wheeler? Okay, two-wheeler means you can bend the bike, two-wheeler, as well as your body. You will tilt. But when you drive a car or four-wheeler, how it can be bent? It is not possible. Therefore, we are raising the outer edge. We are raising the outer edge of the curved road. This is the curved road. This is the inner edge. This is the outer edge. See, this is the road. Now this is a normal road. Now this is a normal road. See my hand. Okay. Now I am going to elevate. That means now it is normal. When you go here, I am just elevating. Now I am just elevating. Now I am elevating. Now it is here. After that, slowly decreasing. That means elevating the outer edge. That means raising the outer edge of a curved road is called banking of the road. Then I can define the phenomena of raising the outer edge of a curved road is called banking of road. Now, what is the use of it? By raising the outer edge, it will provide the centripetal force. Okay, the vehicle will bend towards inward. It will provide centripetal force. That means you can travel with increased velocity. That means increased velocity means you should not confuse here. Increased velocity means when you travel in a curved road, you will reduce. Otherwise, the vehicle will skid. Therefore, in a bike you are bending. But for a car, you have to slow down the velocity. If it is increased means you can go, increase the outer edge means you can go with normal velocity. That means with some permissible velocity, you can drive. That means without skidding, you can drive. Now this is the normal road. Now this is the elevation. That means this is the angle of banking. This is the angle of banking. This is a banked road. Now this is the angle of banking. I will draw the curve, diagram. Now you carefully watch the diagram. In exam, if you draw how I am drawing, then you will not get any confusion. You can easily draw in the exam. Now, this is the horizontal surface. This is the horizontal surface. Now that means this surface. Now I am increasing. That means this angle. Okay, this is the angle. This is the elevated portion. That means this is the elevated portion. Now this is the angle theta. I am calling this angle of banking. Okay, it means this is the angle. Now this is the elevated, this surface. Okay. Now assume the vehicle is here. Assume the vehicle is here. This point is a vehicle. Now weight is always acting towards the center of the earth. Weight mg, that is W equal to mg, is always acting towards the center of the earth. Now the normal reaction is acting normal to the surface. The reaction R is always acting normal to the surface. Now, in a normal ground, if this is some object or vehicle maybe, now this is the weight mg, then reaction will be along the line. It's a plain road. It's a normal horizontal road. Now weight is downwards and reaction is upward. Both are along the same, both are along the line. One is downward, one is upward. But here both are not in a line. One is towards the center, one is normal to the ground. Therefore here we have to resolve R into two components. We have to resolve R into two components. Now according to mathematics, this is the theta. If this is theta, then this will be the theta. Now you can resolve R into two components, normal reaction into two components. Now if this is theta mean, this is horizontal surface. Theta, this is horizontal surface. Now horizontal surface is R cos theta. Already you know, whenever theta is there and adjacent side is always cos theta. Now this will be the vertical side. This is the vertical side. Opposite to the vertical side is, this means sin theta. Opposite you can write. Therefore this will be your R sin theta. This will be your R sin theta. Now R is resolved into two components. Why we have raised the platform? To provide centripetal force. To provide centripetal force. Therefore you can write here F as the centripetal force. Later I will explain. Now this is the theta. Okay. If this is theta mean this is theta. Now again we can resolve R into two components. Okay. F into two components. Now this is theta means this is horizontal. Therefore you can write here as F cos theta. F cos theta. Okay. Now if this is horizontal component means this is vertical component. Therefore here you can write here F sin theta. F sin theta. Now diagram is over. Okay. How I have drawn? Let us consider AOX. Okay. Let A be the horizontal road and OX be the inclined plane and theta be the angle of banking. Now this object, let us say this object, this is the vehicle. Okay. Now the weight is acting downwards, reaction R is acting upwards, that means normal to the ground. Now R is resolved into two components and this is a horizontal component, R sin theta is a vertical component. This force is resolved into two components, F cos theta and F sin theta. Now diagram is over. You have to draw in this order. Then only you can easily draw without any confusion and without changing any cos or sin theta. Now we can write equation. Now we can write equation. Before that you can simply write what is angle of banking also. Angle of banking without providing this F you can simply write. Okay. How can you write R cos theta? R cos theta equal to mg. Without friction you can write. And R sin theta equal to, this provides centripetal force, therefore mv squared by R. Now if you divide this, R will get cancelled and this will become tan theta. Tan theta equal to mv squared by R into mg. Now mass will get cancelled. Now tan theta equal to v squared by rg. This is the angle of banking. Now we will find the velocity of the banked road. Here I have not taken F value, just to find the angle of banking only. Therefore I have taken this mass, that means weight, and this reaction and centripetal force, because this R sin theta provides centripetal force here. Therefore by this I have calculated the angle of banking. Now see how I am writing the equation. Okay, it is very simple. This force R cos theta is upwards from this point. Therefore you write R cos theta upward, and from this point downward force is equal to F sin theta plus mg, because in the downward, from this point downward, these two forces are acting downwards. Therefore, the force upward is equal to force downward. Therefore, r cos theta equal to f sin theta plus mg, because these two are in downward. Now you write this equation 1. Now this force, that means F is resolved into two components. Okay. Now in this direction there are two forces. One is r sin theta plus F cos theta, which provides centripetal force. Already you know centripetal force formula is mv squared by r. Therefore you can write here mv squared by r. Now this is equation 2. Okay. One first equation and second equation. Now we can proceed the derivation. From the diagram, you have written two equations, one along this line and another along this line. This line you have to remember is providing centripetal force mv squared by r. Now from this, just rearrangement, mathematical rearrangement. Then you can easily derive the final result. Now we are going to find v squared only. Therefore, and it is related with mass. Therefore, you keep this term right hand side and bring this to left hand side. Now, r cos theta minus f sin theta equal to mg. Okay. Now here also, here only one term is there, therefore not necessary. Now this is the derivation related to friction. Okay. When the car is moving, then it will have friction also. Therefore, it is related to the friction. Therefore, F equal to mu r. F equal to mu r. This formula already you know. Now you have to substitute this formula here. Okay, for the F you have to substitute. If you substitute here, r cos theta minus mu r sin theta equal to mg. Now you take this r common. You take this r common, because I have taken two equations. Therefore, I am differentiating this. First equation I am taking and I am simplifying the first equation. Now you take this r common. If you take r common, r into cos theta minus mu sin theta equal to mg. You take this equation 3. Okay, this equation 3. Now we have applied mu r for f. Here also you apply. Now this r sin theta plus mu r cos theta equal to mv squared by r. That means I have substituted f equal to mu r. Okay. Now you take r common. If you take r common, r sin theta plus mu cos theta equal to mv squared by r. You keep this equation 4. Okay. We have written two equations and I have just modified. How we modified? We simply substituted f equal to mu r and we have taken r common. Now we have two equations. Our aim is to find velocity only. Therefore, in these two equations, the fourth equation has velocity term. Therefore, you divide 4 by 3. You can divide 3 by 4 also, but if you divide 4 by 3, your velocity term will be in the numerator. If it is the numerator, it is easy to solve it. Therefore, we are dividing 4 by 3. Now I can write equation here, okay, or I can erase and write also. Now I am writing the fourth equation for your convenience. Okay, here r sin theta plus mu cos theta equal to mv squared by r. This is equation 4 I have written and dividing by equation 3. Therefore, divided by r cos theta minus mu sin theta. which is equal to mg. Therefore, it is denominator. Therefore, I am writing the denominator only. Denominator I have written. Okay. Fourth equation I have written, and third equation I have written. Okay. That means this is 4 by 3. Equation 4 divided by 3. Now I erase it. Now this RR will get cancelled, and you are having sin theta plus mu cos theta divided by cos theta minus mu sin theta, which is equal to mass get cancelled. You are getting v squared by rg. Okay, but this is the equation. This is enough. But usually we will write in the form of tan equation. Therefore, after this, again simple mathematics only. Now we want tan theta. Tan theta means sin by cos. Therefore, here sin is there, cos is there, but we have to write sin by cos. Therefore, here you take cos theta outside as common. Now, cos theta, I told you, I am taking outside in the numerator first. Here two terms are there. I am taking cos theta outside, but here there is no cos theta. Therefore, I am writing sin theta by cos theta. For non-math students, please listen. If you multiply by cos theta, then sin theta will be there. Only sin theta. Therefore, I am writing sin by cos plus mu. Because cos theta I have taken outside. Now, if you multiply, you will get this term only. If you multiply cos, cos will cancel, sin theta. If you multiply here, mu cos theta, which is equal to v squared by rg. This is numerator. Denominator cos theta, I am taking common. Therefore, 1 minus, I have taken cos theta outside. 1 minus mu sin theta divided by cos theta. Why divided by cos theta? Because only sin is there. I have taken cos outside. If you multiply, cos will cancel, sin theta will be there. Now you cancel this. Then what will be your result? I will erase this. Your result will be sin by cos tan theta. Your result will be tan theta plus mu. Tan theta plus mu divided by this one, 1 minus mu tan theta, which is equal to v squared by rg. V squared by rg. Now our aim is to find velocity only. Therefore, v squared equal to rg will go to the next side. Therefore, rg into, just I am interchanging left and right. Here, tan theta plus mu divided by 1 minus mu tan theta. Mu tan theta. Now this is the velocity for the banked road. Now already you know the formula v squared equal to mu rg. This is the formula already you know for the velocity of a normal curved road. This is also v squared mu rg. This v squared mu is there, but we are having some additional term. Now due to this additional term, the velocity is greater than the normal road. That means due to this banking, you can go with little more velocity than normal curved road. Okay, thank you.